So probability is always a fun subject to teach. Well, here we have a fantastic activity that introduces students to probability and a pretty elaborate example that'll have them apply reasoning, questioning, researching, and critical thinking skills to find a solution. So here's our scenario. We have Jack, this crazy climber who's halfway up a 200-meter cliff. For the next hour, he's going to play a game where he's going to flip a coin. If it lands heads up, he's going to go up 10 meters. If it lands tails down, he's going to go down 10 meters. What's the probability of Jack either reaching the top or the bottom of this cliff face? So here we're going to ask students to place a stake in the sand. What do they think? Will he always get off the cliff? Will he sometimes? Will he seldom? Or will he never? So what do you think? When we're dealing with probability, we want to associate it with a number. So the likelihood of a particular event happening is probability. So if it's likely to happen, then we have 100% or a probability of 1. If it's unlikely to happen, then we have 0% or 0 probability. A way that we can calculate the approximate probability is to perform the event many times. Jack's situation is a little bit more complex though. To approximate the probability that he will get off the cliff, we need to toss the coin 60 times just to perform one trial. Then we need to run that more times for more trials. So the best way that we can do this, and the only way that we can do this, is to create a model. So here's what we're going to do. We will have students launch Excel, and they will be guided through the TechSteps digital book to build their model. And when we're dealing with Jack's climb, we're dealing with random movement. So to simulate the coin tosses, we're going to use the random function. So here's our formula. The random function creates a random number greater than or equal to 0 and less than 1. Because Jack is halfway up the cliff face and the random number is less than 1/2, we know the coin landed tails up and Jack's new position is his old position, minus 10, or he moves down 10. If the random number is 1/2 or greater, then the coin landed heads up and Jack's new position is his old position, plus 10, or he moves up 10. And we're going to simulate this climb for 60 minutes or 60 coin tosses. So we'll drag the formula down to cell A62. Every minute we are randomly adding and subtracting 10 from the previous position. So we're going to be asking students questions along the way, making sure students understand what plus 40 would mean and what negative 20 would mean. They're going to be interpreting the data. So the next thing we will have students do is determine Jack's success. And here's our next formula. We want to deal with a true-false statement. And we know that if Jack reaches negative 100 or less, or positive 100 or more, he got off the cliff. So max A3 to A62 finds the greatest movement up, and minimum A3 to A62 finds the greatest movement down the mountain. So we're still just dealing with numbers, and I don't know about you, but a graph or picture always seems to tell the story. And because we're dealing with discrete data, Jack flipping the coin every minute, then we can choose a scatter plot to represent the data. So I'll select my data, then select the Insert tab and go to Charts and choose Scatter Plot, and then select Scatter Plot with straight lines and markers. And here we go. But we do need to add our constraints to this, and we will format our axes. So we're going to right-click on the vertical axis, which represents our climb, and then we're at our constraints. We know that the minimum number would be negative 100 and the maximum number would be positive 100. Then we choose our horizontal axes, which represents our coin tosses, and our minimum would be 0 for no coin tosses, and our max would be 60 for 60 coin tosses. So here we go. We have our model, which represents our coin tosses and Jack's success, utilizing the random number generator, the true-false statement, and a scatter plot to represent the data. If we really want to be creative, we can add a background so we can visually see Jack's climb come to life. So using the Format Plot axes, we can insert a photo. Here we have a perfect example of a mountain face, and then modify the transparency of the photo so that we can see our data values. Finally, reflection. It's important to bring everything back down to our academic standards. So we will have students reflect on how the graph helped to convey the information, when they might need this model in the future, and what features of the spreadsheet helped them. I hope you enjoyed Random Climb. To learn more about our project-based activities, please visit us at www.advation.com.